only about 40, 45 minutes or so from Ian. So Ian's very kindly agreed to do this twice. We've just realised that, of course, that means he doesn't get any lunch, so if he faints during the second one, we'll try and sort him out. So Professor Ian Morison, who's one of my colleagues here at Jodrell Bank, has the benefit of having retired, actually, so it's very, very jealous of him, but he's still working very hard. He's going to tell us all about the search for life on the Earth. Thanks.
Thank you very much.
Have you unmuted yourself?
1, 2. Is that better? Yes, I'm unmuted now. Okay. Well, as Tim said, I actually still come out here a couple of days a week. I've been doing a project, in fact, to do with pulsars, as it happens. They just forget to pay me anymore. That doesn't really matter. And I can do other things as well. So this is something I was directly involved. Bit loud, too loud. Is that all right? Touch more. 1, 2, 3, 4, 5. 6, 7, 8. That's about right, Tim, I think. Okay. And as you'll see, I was, as was Jodrell Bank, directly involved in this story, as we shall see a bit later on. So the talk is the question: are we alone? Are there other aliens out there that we could somehow come in contact with? Just as a start, a little bit of an aside, not really, is to try and give us an idea of what we should be looking for. I've called this star stuff. Our sun is creating energy in the core by converting hydrogen to helium, as I'm sure you all know. But eventually, in about another 4,000 million years, that hydrogen will run out. Then the star completely changes its size and everything, and that hydrogen, which has been converted to helium, that then turns firstly to carbon, and then a part of that into oxygen. Slightly more massive stars than our sun produce a lot of nitrogen. So, hydrogen, oxygen, carbon, and nitrogen are the most common elements in the universe. And I think it's fair to say that carbon has the most interesting chemistry of any element. I did organic chemistry at A-level. Anyone else do that, perhaps, in my generation? So I suspect, on those two grounds, that virtually all other life forms in our universe will be based essentially on the same elements and the same chemistry. So that's probably what we should look for. And that probably means, too, that water needs to be a liquid. Now, it would be no use if those elements stayed within the stars that created them. But happily, at the end of their lives, stars blow up, and this is a picture of what's called a ring nebula. The outer parts of the star have blown off, and the red colour there is, I think, hydrogen, but the lovely turquoisey colour is oxygen. The little white dot, do you see right in the centre there? Well, that's what's left behind. It's the remnant of a nuclear fusion core. It's very, very hot. It's currently called the white dwarf, but I think the name is changing to white dimensionally challenged object before too long. More massive stars, because they've got greater gravity, they can have greater pressures in the core, and that allows nuclear fusion to carry on to create elements up to iron and nickel. But then in the supernova explosion, you've heard about those already today, in just a few seconds, all of the heavy elements are created. So over time, the space between the stars has become enriched, not just with the elements I've talked about, but the heavier elements like silicon and iron. And that allows dust grains to form, and that means that later generations of stars are able to have planets around them, like our own solar system. So where should we look for any other life forms? Well, the obvious first place is in our own solar system, because we know our solar system is a good one for life. Why do we know that? Because I'm talking to you. It's very obvious. So let's have a look. Well, the first obvious place to look is the planet Mars. They call it the red planet. It actually looks rather salmon pink, in my view, anyway. Way back, Percival Lowell produced this lovely chart of Mars, or picture, showing these lovely canals that they used to think were to use to bring water from the polar caps to irrigate the crops. And they really did think there was an advanced civilization on Mars. Well, now we know, of course, that wasn't true. But when spacecraft first got there and took high-resolution images, they found a giant canyon Valles Marineris, 5 times bigger roughly than the Grand Canyon, but also 4 giant volcanoes. There's actually 1, 2, 3, and there's one just over the edge there you can't see, but if we zoom round a bit and look down, we see Olympus Mons, the largest volcano we know of, I think, in the solar system. The caldera is 60 miles across, if I'm allowed to use old money, and the overall width is about 500 miles. Now, when those volcanoes were active, 4,000 or so million years ago, not only do they produce lava and ash, but they produce a lot of gas: ammonia, methane, carbon dioxide, and water vapor. Carbon dioxide, methane particularly, and water vapor are so-called greenhouse gases. So when the atmosphere then was much thicker, it also became much warmer. So the water vapor could form droplets that could form as rain. And we know then that Mars, as you'll see, was covered by a significant amount of water. And they keep on saying, oh, we've discovered evidence of water on Mars. These pictures come from years and years and years ago. Can you imagine either of those pictures being formed without water flow? I mean, I lived by the seaside, and we used to make dams, and when you broke dams, do you remember that sort of thing? Have you played at the seaside? And look how the water has passed, or something has flowed past that crater there. So, 4,000 million years ago, Mars was pretty wet. But sadly, it has no magnetic field, and that cannot therefore help prevent the solar wind from gradually stripping that atmosphere away. So over time, the amount of water on the surface became less and less and less, and now there's no free water essentially on the surface. I'll come back to that a little bit later on. So you see, it's not impossible that a few thousand million years ago, simple life could have formed on Mars. So people have been to look. First of all, in '76, 2 Viking spacecraft went. And they had scoops, they took some soil from in front of them, they put it inside, and some little chemical experiments, one of which they added baby bio to the soil. I've got some of that to try and make some of my plants at home work a bit better. It's not very good. Anyway, it was very clever baby bio, because it wasn't normal carbon-12. It was based on radioactive carbon-14. So they could trace what happened to it, to see if it was ingested or came out as something else. Sadly, no evidence was found. 2 little rovers have been going around Mars. They found on the surface little things called blueberries, which you could only possibly form underwater. They thought they'd last for perhaps 6 months, because the power comes from a flat solar panel. We all know Mars is incredibly dusty. Sometimes it's completely covered by a dust storm, and you see nothing at all. So they thought the power would drop over about the first 6 months, and it did. It went down to about 60% of the rated power. But suddenly it went up again. It's all down to James Dyson. You've seen in America on the desert, you get little twisters, little vortices, just like in these vacuum cleaners. On Mars they're writ large. And as one comes nearby, it acts like a vacuum cleaner and cleans the surface. Isn't that wonderful? One of these has been trundling around the surface for nearly 10 years. You've all heard, I think, of Beagle 2. It was designed and built by the Open University under Colin Pellinger, and it was due to land on Christmas Day 2003, having left its mothership, Mars Express, on the 19th of December. And Tim and I were actually project scientists on that mission in a minor way, and I certainly watched it leave its mothership on a giant screen down in London. Now, the point is this: these little things have little power. They can't transmit signals that are very powerful, so they transmit up at a low frequency to a mothership that's orbiting above, and that was Mars Express. But Mars Express wasn't going to get there for about 8 days in the right sort of orbit, so they desperately wanted to know that Beagle would have arrived safely. And so we at Jodrell were asked if we could detect the signal directly from the surface. And I promise you, hand on heart, which I think is about there, this telescope is the best in the world at detecting signals at the relatively low frequency that Beagle would have transmitted. We built an incredible receiver, the best in the world ever built at these frequencies, partly because it used superconducting components made for us Birmingham University to cut out all the terrible terrestrial interference. So we went out there early on Christmas morning, and can you see the little red dot? I know the sun's not helping, but there is a red dot there, and that was Mars. I've slightly enhanced it in Photoshop, but it was there, and we were very careful that we were looking in the right place. We had about 4 computer programs all telling us where Mars should be. And we had a wonderful screen. This was actually developed by Tim. And along the bottom is frequency, up the side is time. Now, it's not easy to see. It might be easier on these screens here. Can you see a vertical line over at the left?
Yeah.
That's staying at the same frequency. It's local interference. It's something from Jodrell back. But not so easy. There is down the bottom here something curving. Do you see over there? That's changing its frequency. And that's in fact a satellite orbiting the Earth. And it may not be possible, but there is in fact a curve up here, a very gentle one, which is a satellite orbiting the Sun. This was an incredibly sensitive system, I promise you, hand on heart. Beagle should have been coming up here loud and strong, but nothing was seen. And we actually tried looking for it over a period of about a month, because there were various wake-up mechanisms they built in. So we didn't know what had happened to it until last year. But an orbiting spacecraft imaged, we believe, the rear cover, the parachute, and Beagle itself. And blowing up this bit, you can actually see Beagle down here. And the trouble is, it had several little panels that folded out, solar panels. And it looks as though only 3 of the 5 had actually extended. It got to the right place. It just couldn't work. And that's very sad. The saddest thing of all is that Colin Pellinger, whose baby this was, died just a few months before we found it. So I think that's a bit sad. Anyway, that was our try, and it was great to be involved, but sadly we didn't pick anything up. I'm pretty good. I never find anything I look for, except, in fact, one of the black holes on that chart of black holes I did discover the location of, and that was a long time ago. Okay, and then the Phoenix lander, that dug a trench, and here you can actually see some ice. There's a permafrost under the surface. We need to look under the surface in a way, and Curiosity rover's been trundling around. This is a wonderful, it's a selfie actually, brilliant. And it can't dig into the soil, but before too long, you'll see the ExoMars rover will have a drill. Now, just look at these pictures, and I know the sun isn't helping actually behind it. These have been seen for a bit. Streaks down the sides of a canyon. Look at that picture, you see almost nothing. In this sequence, can you see the streaks appearing, disappearing? Now, what we think is going on is that the side of a canyon, if the sun is falling down on it, can get to about -20. At that temperature, brine, or solid brine, shall we say, an ice, but very salty ice, can actually melt. And we think there might be transient water flows, or brine flows, going down the side. So there's some evidence there that there is in fact a permafrost, and occasionally there is something that's liquid. Now, why is that interesting? Well, this is a hot water spring in New Zealand I visited last year, and the water comes out at about boiling point, but you can see there's some white things around here, and those in fact are organisms called extremophiles that can survive under those very extreme conditions, where it's very, very hot. Now, of course, that's not the case on Mars. But if you actually go to Ellesmere Island in Canada, in those ice flows, in the ice, you see cracks which contain brine. And in that brine, you find these things here. It's called Planococcus halocryophilus. So the cryo, cold. So there are things that can survive and possibly even reproduce under conditions of about -15 or so. So it's not impossible that if life did once evolve on Mars when conditions are much more favourable, it could have evolved so it can still possibly exist. And as I said, ExoMars will get there somewhere around 2020, 2021, and that's going to have a drill so it can actually look down into the permafrost to see if it can find any evidence of life. Now, you might well say, well, as you get further out in the solar system, it's far too cold. But that's not the only form of heating. Our moon causes tides on the Earth. Little stones run up and down the beach. They rub together. A little bit of frictional heating, not much. But if you're close to Jupiter, that's writ large. And when they first took pictures of the Galilean satellites, Io up here looked very interesting. It's actually pockmarked with volcanoes. It's the most volcanic region we know of in the solar system. So the interior, at least in part, must be molten. And that's called by the tidal flexures. I think in the middle of the Earth, or the oceans, the ocean goes up and down by about 1 metre. Here, the surface is doing this by about 40 metres. So the friction that's caused makes it volcanic. Now that's obviously terrible for life. But if you go out, oh by the way, sorry, do you see? Little active volcano. If you go out to the next moon, which is Europa, in complete contrast, it has a very, very smooth surface, but you see these dark markings. They're actually the results of tidal stresses. And we think what happens is you get cracks in an ice surface which is overlaying an ocean of liquid water. And if you look in detail, you can sort of see icebergs. Can you see that there's a crack there? That must have joined up at one point, and so on. I don't see the Titanic, but nevertheless, this I think is very good proof that there was liquid water under the surface. So the surface actually is continuously being recreated. And last year, the Hubble telescope found evidence of water plumes. You see artistic sort of representations here of jets of water that come out along cracks through the surface. Now that's very interesting, because it means that you could have a spacecraft that could fly through those plumes and look for any evidence of organic material or even life itself. If we did find it, we might someday have a spacecraft that burrows down through the crust and goes round to have a look. Well, that's not the only place. Saturn has got a lovely moon called Enceladus, again very interesting surface, and they've actually photographed already the plumes of water vapor coming out. And although we don't think there's a full ocean under the surface, we do think around the poles there are pockets of water. So that's 3 places in our own solar system where we might possibly find evidence of past life, or even present life. So what can we do beyond that? Well, you've already heard, we now know of 1,000 or getting on towards 2,000 other planets. Can you see them? Well, I used to set exam questions saying, why can you not see any exoplanets? And that's simply because the planet's very, very faint compared to the star. It's like trying to find a little sort of a candle flame against a searchlight that's pointing straight at you. And in fact, on one of the occasions, I had to actually have the exam question changed in proof because they'd done it. It's easier in the infrared. The Kepler telescope has actually seen 3 planets orbiting the star. This is the light from the stars being removed as much as possible. They're more obvious on that display there because of the sunlight. And it's been done a few times. But it won't be done very often because you've got to have the planets quite a long way away from the star, and the star's got to be very close to the Earth. There are other ways of doing it. The one that's been most prolific recently is very simple. If a planet goes in front of a star, it obviously reduces the brightness slightly. It only works, of course, if the planet's orbit is in the plane, or the Earth lies in the plane of the orbit of the planet. And that's a real transit you can see there. And you learn a lot about the planet from this, the size of it and so on, how far away it is from its sun, and obviously you get the period because this repeats over and over again. If it doesn't repeat, you don't know what it is. And this is one of them, 150 light years from Earth. But many of these planets that have been found, partly because they're the easiest to find, are very close to their star. This one orbits every 3.5 days. Mercury's 80 days. Is only 4 million miles from the star. Can you see it's going to be very, very hot? Surface temperature about 2,000 Kelvin. Not good things for life. And there's a worse aspect to this actually. You cannot make giant planets like that close to their star. They've got to be made about where Jupiter is, in our solar system. Somehow, it's a typical thing, it's got to work its way in towards the sun. Do you see that? In doing so, any little planets that lie in the way, like the Earth, would get thrown out into the universe, or into space, into the galaxy. So they're not good solar systems for life. And the real problem is that solar systems like our own are much harder to find. Kepler, that actually has found many of these. There's Kepler. That's looking at a region around Cygnus to Swan, almost overhead actually, late at night at the moment. The hope was it would actually find a lot of Earth-size or Earth planets, which go round once every year. But can you see, if that happens, you've got to watch it at least for over a year. If you're lucky, you might catch it once and then immediately the next time. Ideally, you want it to do it more than once. So 2 to 3 years is what you need. And sadly, one of its gyros failed. It hasn't really worked for as long as we hoped. So the finding of planets like the Earth at the distance of our planet from the Sun is obviously hasn't really worked as well as it was hoped. But you can look at the number of, these are the planets that have been discovered, just announced in 2014, all done by Kepler. And they have found a sort of holy grail. What we want is a planet Earth-size, this one actually is about 5 times bigger, but within what's called the habitable zone, the Goldilocks zone of its star. And ideally that star wants to be similar to our Sun, so it lives a long time to allow life to evolve. Can you see that? And this one, this Kepler 22b, lies within the habitable zone of its star. So that's the first planet we found where we think there could be liquid water in principle on the surface. There was a bit of fuss made the other day about a planet. Do you remember orbiting Alpha Centauri b? Does anyone remember seeing that? The trouble with that is, it's a little red dwarf star. It's Proxima Centauri, I should say. And they flare a lot, and that's not good. Lots of X-ray flares. But you have to be so close to be warm enough, as it is. Can you see one side might get locked, like the Moon is to the Earth? So that side gets very hot, and the back gets very cold, and everything freezes out. Do you see the problem? So personally, I think that's perhaps been hyped up a little bit too much, but that's life. Things always tend to get overhyped. I'm sure you're aware of that. Anyway, now, okay, there is a planet. In Chile, last year, they laid the foundation stones for what was going to be called OWL, the Overwhelmingly Large Telescope. And they decided they couldn't actually build it, so it's now just the Extremely Large Telescope. But the first thing, or one of the first things that will do when it's commissioned, or being commissioned, I suspect, is to look at that planet. Supposing you were there looking back at the Earth, can you see you might spot changes in the reflectivity during the day, the continents and the oceans? And also, maybe, changes throughout the year. You know, the tops of our planet tends to get a bit covered with ice and snow. Do you see the differences? That would be very interesting. Could you actually get any evidence of life from any of these extraterrestrial planets? Well, you could, surprisingly. If you look at the infrared spectrum of a planet, now that's ours in front of the Earth, which makes it hard to see, so I've removed the Earth, and it's a bit less boring, but there we are. Now, in the absence of anything interesting, this would be flat. This actually is in the infrared. It's flat down, oh, it's down here and down there, and that's caused by water vapour. Is that good for life? Thank you. It has a very big peak of CO2. Now, I know we all hate CO2, but if it wasn't there, the Earth would be too cold. It would be about -20. I promise you. And I will also say the Earth has been about 10 degrees warmer than it is now in the past, and we didn't cause that with our cars, did we? So I think it's a very complicated thing. But nevertheless, CO2, that's also quite important, and I'll come back to that later. Bit of CH4, methane. Well, a lot of animals make methane, particularly cows. I think I read of a barn in Scotland that blew up because of the methane. That's about 2 years ago. Okay, but now this is the key thing. O3 is ozone. You've heard of the ozone hole, which I think is filling up, so I read the other day. Now, ozone is highly reactive, as is oxygen. It used to turn my British landing cars into rust quite quickly. And my wife was given a Fiat, and they never bothered to rust-proof Fiats. This is 30 years ago. Yeah, about 30 years ago. And the floor fell out. So, unless you replenish the oxygen in the atmosphere, it just disappears. So the fact that we have oxygen in our atmosphere is because of plants, photosynthesis. So if we saw ozone, which means there's oxygen there, we might know at least the sunlight life existing on the planet. So that's about the best we could do. And just as a comparison, there's Venus, okay, CO2, as we expect, is 100 times more than on the Earth. Here's the Earth, quite complex. Here's Mars, also CO2, but about 100th that on the Earth. So we do have a chance of perhaps detecting evidence of life on nearby planets. Well, what can we do beyond that? Well, we can't do it by ourselves. We could only do it if somebody out there tried to tell us that they were there, or possibly we could eavesdrop on two other intelligent civilizations communicating one to the other. And that would be harder. The subject's called SETI, the Search for Extraterrestrial Intelligence. And the very first paper by Goldeneye and Morison, who's no relation, I'm a 1R Morison, and originally Morison was spelt with 1R, but in the late 1800s most of them changed to 2. I don't know why. In my case it saves ink. Anyway, now, I think they were inspired, seriously, by the building of our Mark I radio telescope in '57, because they realised that given 2 radio telescopes of that size, you could in principle communicate across interstellar distances. Okay? Now, it's a very good paper. It was in Nature, which is a pretty prestigious journal. I think I've published in there 3 times. I'm very proud when that happens. Anyway, the point is this. Where did you first look? Now, if you've lost something, isn't it good to look at the places you're most likely to have left it first? So they said, well, where is it most likely for us to find life on other planets? About stars like our Sun, because our Sun is good for life. 2 reasons. It's quite hot, so you don't have to be too close to be warm enough, all right? So you don't get tidally locked, okay? But also, it's not so hot that it doesn't live long, because the hottest stars don't live for very long. And our Sun will live for probably 8,000 million years, maybe more. So you need those 2 things. So what we're looking for are Sun-like stars. That's what they're called. And they gave a list of the 12, the nearest ones, and 2 of those, Tau Ceti and Epsilon Eridani, are just visible to our unaided eye. I used to say naked eye, but apparently that's politically incorrect now, and we had to say unaided. Anyway, okay. So they gave a list. Now that's not too difficult. The next question, though, is where should you listen? You know, what frequency? I mean, do they have the radio times? Do they know the frequencies of the light program in the home service? I suspect not. So what do you do? Well, actually, that problem was solved. It was actually solved essentially the year I was born, which was 1943. Some physicists in Holland, presumably under the Germans at that time, calculated that hydrogen, the most common element in the universe, would give off a very, very precise frequency, about 1400 megahertz, which is similar to the sort of frequency that some of the lesser spec laptops sort of work. All right? So we know a frequency. Now, can you see, if anybody out there is capable of transmitting signals to us, they have to have physicists and be at least the same technological advancement as us. They would know that frequency. And they would know that we would know it. And they would know that we would know that they would know it. So there is a frequency we know we can use. Now, in fact, a little bit higher up in frequency, there's another frequency to do with hydroxyl, OH. And H plus OH makes water, H2O. So perhaps in the same way that animals in the jungle meet at the Waterhole, so maybe communications across the galaxy happen in what we call the Waterhole in the radio spectrum. And the good thing about it is that it comes in, oh sorry, I didn't mean to do that, it comes in the part of the spectrum where the background noise from the atmosphere and the galaxy, etc., is a minimum, which is why just below this is where all our mobile phones work, which prevent, in fact, a limit to what we can do with our radio telescope. Look, if we're looking at galaxies, hydrogen line, okay, it's 1420 megahertz if they're nearby. Can you see the further away they go? They're moving faster from us. Their Doppler shifted downwards, and there comes a point, because of the mobile phones, we can't pick them up anymore. And higher up, you've actually got, oh goodness, I'm not doing very well here. Higher up, you've got the point where the satellite televisions work. So that's a good part of the radio spectrum. All very good. The following year, 1960, Frank Drake organised Project OZMA, at Green Bank, which is the American equivalent of Jodrell Bank. It has one very big telescope, we'll see later, the current one, and some smaller ones. This is a bit the same size as our Mark II across the field. Why was it called Project OZMA? When I was a little boy, I was taken to a first film, and it started in black and white and turned into colour. OZMA, the mythical land over the rainbow. All right? Okay. They had about 3 months. The second day of observations, they picked up an intelligent signal at the radio frequency around 1420 megahertz. That part of the radio spectrum is allocated to radio astronomers to study the universe. No one but no one is allowed to transmit there. So what could it be? Well, a couple of weeks later they picked up again, and this time they proved it wasn't actually coming from beyond the solar system, but it was very, 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 very high up in the atmosphere. Any clues from that? 1960. No. In 1962, Gary Powers was shot down in the U-2 spy plane. And these slightly sneaky Americans, I have to actually give them some credit for this, said, well, if we use that part of the radio spectrum as our downlink, no one will pick it up. Because radio astronomers have broadband receivers, they don't pick up that sort, but this wasn't, you see. So that's quite clever. Anyway, so that was quite, there we are, U2. So what's been happening more recently? And I suppose the current set of SETI observations really began around sort of 1997, 8, 6, something like that. There was, in fact, I'm not telling you this bit, so just close your ears, will you? NASA had a SETI program, as we shall see. They built a fantastic receiver. It was a spectrum analyzer. It could analyze the radio spectrum brilliantly, better than any other receiver in the world at that time, 1982, I think it was. And it came to Jodrell Bank. And nominally, it was to check out the interference environment of Jodrell. In fact, it was to discover a secret Russian satellite, which it did. But we used it to do some fantastic astronomy. So anyway. Now, let's start. Have you seen the Bond film Goldeneye? Yeah. It's got the dish of Arecibo in there. And I think Bond and the baddie had a fight up the top and the baddie fell down. So that was horrible. Now, Brosnan, I liked him as a Bond. He was here, but they never let him go up the top. There's actually a little tripwire thing, but you normally walk up here. I was out there, I don't know how many years ago, with a group of British astronomers, and only 4 of us out of 12 allowed ourselves to go up. It was actually quite exciting. Anyway, the point is this. That was, and maybe for another 2 weeks, the world's biggest radio telescope. Why I say that, we'll come to a bit later on. So it's the most sensitive. Well, it was until we built E. Merlin, actually. It's a slightly more sensitive system, but it doesn't matter. Now, that's been used, and still is, by the University of California at Berkeley. And they basically look wherever that telescope's looking. And over time, it's several years now, many years, it looks at the same place many times. They're looking for signals that are seen every time or several times when they look in a particular direction, in case someone is directing a signal at us. And they did find some. But sadly, all was shown to be local interference. And that is a problem using just one telescope. Now, SETI has a NASA had a SETI project, and I mentioned it briefly. But they developed a system, it was done by the SETI Institute on NASA's behalf, where they had 2 telescopes, well separated. Can you see local interference at one will not be picked up by the other? So, and also, in fact, more subtle, because the Earth is rotating and the Doppler shift, if you take that into account, if this receiver picks up a signal, the one halfway around the globe or away has to look at a slightly different frequency. Do you see that? In fact, together, they are only sensitive to signals that come from beyond our solar system. So it's a very boring experiment because you never get any false alarms. The trouble was that every line of the NASA budget has to be agreed to by the Senate and Congress. And a group of senators under Senator Proxmire decided it was hard enough finding intelligent life in America, let alone beyond the solar system. And they cut, and it's a bit unfair, but are they going to elect Trump? Could be right. Anyway, the point is this. They cut the funding. But Jill Tarter, the director of the SETI Institute, she went out and got private funding. Anyone remember the film Contact? Yeah. Jodie Foster, I think it was, she did the same thing. And they carried on under the name, you can't see it, it's down there, Project Phoenix Arising Out of the Ashes. They started with 2 telescopes in Australia, then 2 telescopes in America. But before the funding was cut, they'd actually bought, in effect, time on the refurbished Arecibo Telescope. Essentially 6 weeks a year for 5 years, because NASA had funded quite a bit of the upgrade. And they needed a telescope to work with it. Now, look, if you're using a 300-foot telescope, can you use a 10-metre dish to confirm signals? You can't, can you? They need something big. And by pure chance, I was sitting next to the project scientist for Project Phoenix at a conference there in 1996. He told me what they wanted to do, and I said, why don't you use our Lovell radio telescope? And that is what happened. And the kit came here in 1998. We started observations that autumn and carried on and off over 5 years. We looked at 820 Sunlike stars out to about 200 light years. And I promise you, that was the most sensitive search ever undertaken. Now, you haven't asked, but you might. If you never picked anything up, how on earth do you know it was working? Well, every day, before we started our observations, we looked at the signal of the Pioneer spacecraft, one of the 4 spacecraft that's left the solar system. 2 Voyagers, 2 Pioneers. And we could prove each day that our systems were working. Well, ET did not phone home. It's not really too surprising. I said that the furthest star we looked at was 200 light years away. How big is our galaxy from one side to the other? 100,000. Can you see 200 is nothing, is it? So unless intelligent life was incredibly common, we were unlikely to have detected it. So I'm not sure we should be surprised. That's what we're saying. I just said that. And since intelligent life is very common, we couldn't really have expected to find it. What else has been going on? The SETI Institute got funding from Paul Allen, Microsoft. Yes? To build what's called the Allen Telescope Array. That's looking at the Milky Way. It's an array of telescopes, a bit like a small version of the SKA, but not so many dishes, and they're all rather smaller. It lost its funding after a bit, but happily it's got some new funding that's carrying on. But also, someone called Yuri Milner. He's a Russian oligarch. He's also behind this idea of using laser beams to send a tiny thing off to the nearest stars. Did you see that in the news? I think it's complete rubbish, but that doesn't matter. I really do. The spacecraft would be a gram. So I don't know, it doesn't matter. Anyway, however, he's putting $10 million a year to use 2 telescopes. This is the big one, the new big one, the Greenbank telescope. Now, ours was the biggest for a long time, and then the Germans built a 100-metre dish at Effelsberg, and then 10 years later, the Americans built this one. The German dish was 100 metres in diameter. How big was this one?
200.
Oh, that's a bit much. 105. You're not going to build one that's 95, are you? Certainly not if you're American. It's got to be bigger. So anyway, that's a wonderful dish. And then the other one is the Parkes telescope in Australia. And that's great because it can see parts of the galaxy. It sees the galaxy very well. We've discovered lots and lots of pulsars taking our equipment and using it on that telescope. Has anyone seen the film The Dish?
Yeah.
If you haven't, please do. It's lovely, isn't it? They used this telescope when they had that conversation between Nixon and Armstrong on the surface of the moon. It's a lovely film, it really is. So those are going to be used for the next 10 years, that's great. Now, I said that the Arecibo dish won't be the most sensitive for much longer because in a couple of weeks' time, the Fast Radio Telescope in China is going to be commissioned. And look at the idea. I think we're here. Can you see Jodrell Bank? There's Effelsberg. That's Arecibo, but look at Fast. So that's going to be fantastic. And that could do a good job as well. So there we go. And finally, we can't see very far, but you've heard about the square kilometre array. That would have the sensitivity of looking across a fair whack of our galaxy. So there is a future. Now, whether we'll find, I've got to stop now because we've got to switch you all over. Whether we'll ever find other life out there is an interesting question. My suspicion is that simple life is very common. I think more or less wherever a planet has the right conditions on the surface, simple life will arise. It rose here on the Earth virtually as soon as the Earth could support life. But then it took a very, very long time for single cellular life to turn into multicellular life, perhaps a couple of billion years. It may have happened up to 20 times, so it's not that impossible. But can you see we're needing a planet to keep a very stable temperature for a long time? See that? Now, our moon, I think, has been quite important. First of all, it's actually stabilised the Earth's rotation axis. And that's very good. It stops the poles flipping to the equator. It even stops the Earth's rotation axis pointing towards the sun. Can you see one side gets hot, other side very cold? That's not good either. So that moon's been good. Also, the tidal forces of the moon, when it was very close to the Earth, it is thought may well have helped the formation of what we call plate tectonics, you know, the motions of the crust. Now, carbon dioxide, which I have said is important to keep us warm, gets dissolved in the oceans. Some of it forms little shells which fall to the ocean floor. If that continued to happen, with nothing else happening, the amount of CO2 will drop in the atmosphere and the Earth will get too cold. But those oceanic planets, they move out sideways, they subduct under the continental plates, causing terrible things to happen. But also you get the ring of fire, don't you? The volcanoes. And then put the CO2 back in the atmosphere. So that's actually also very important. So I think the moon is really quite critical. How often big planets will actually have, or planets like the Earth have a moon relatively that big, I do not know. But it's one of the things that's helped. Comets are very important. They brought about a third of the water that I'm about to drink to Earth. And that's good. But big ones, if they hit the Earth, cause global extinctions, wiping out a lot of the Earth's life. Now, if you have one of those every 100 million years or so, that's not too bad because it stimulates evolution. If the dinosaurs hadn't got wiped out by various factors, including, we think, a big impact 65 million years ago, we might not be here because their demise allowed the little mammals to develop into us. But if we got hit every 100 years or 10 years or even 1,000 years, perhaps that wouldn't be so good. And the great thing is we have that giant planet, Jupiter. It basically probably gets 99.95% of all the comets that would hit the Earth to hit it instead. And way back in 85, 86, we saw comet Shoemaker-Levy 9 going to the surface. And we actually were one of the first amateurs in Europe to see the scars on the surface, largely because most of Europe and southern UK were in cloud, and it wasn't up at Jodrell Bank. And that was one. He told you it's always sunny at Jodrell, didn't he? So that's another good thing. So there are quite a number of things that have actually helped our planet have a stable temperature and allow life to exist for several billion years. And I suspect those conditions won't be found very often. Coupled with the difficulty, it appears, of going from single cell to multicellular life, I honestly believe that advanced life like ours is going to be very, very rare. I suspect, honestly, that in our own galaxy, the Milky Way, we are probably the only advanced civilization that currently exists. Hence, we're not very likely to come in contact with any others. I hope I'm wrong, but even St. Brian Cox agrees with me. You must have read my book. Anyway, that's all. No, he did say the same sort of thing in a talk he gave on the telly not that long ago. In fact, I taught him when he was a young student, actually. Amazing. He survived. Anyway, so there we go. So the sad conclusion is there's a chance we might detect simple life forms, Mars, Enceladus, and Europa. Secondly, we might detect the presence of simple life form, cloud life, on other nearby planets. But possibly, but rather unlikely, we might someday detect evidence of intelligent life out there. I hope we do. Sadly, I feel we won't. Thank you for listening. How much time have we got, Tim?
Well, there's 5 minutes till 1:30. So we'll start again at 1:30.
I know we should.
Maybe there's a couple of...
Yeah, a couple of questions. We got delayed a bit at the start, as you probably remember. Anybody got a quick question? Obviously bamboozled. Sir? Yeah, they're all hungry, yes I know.
Returning to Mars,
Yes.
our understanding of the geology and the development of the planet has improved
Yes?
since we've been studying it. How do you see that our understanding might be further improved in the next 10 to 50 years? That might give us more insight into what we're looking for and what we might find.
Yeah, well, we're going to learn an awful lot more. First of all, the ExoMars rover with its drill is going to be able to look beneath the surface. That's incredible. There's already an ExoMars type orbiter looking for methane traces. That could be formed by life. So gradually, will anybody go there? I'm not sure. I'm convinced they will. But if they did, then obviously you could do more. I think we know enough now to say that life could have formed there way back, and almost to say that it's not impossible it might still exist. I think we've learnt enough already. So we're going to learn a lot more, but I think it would be not fantastically much more. Does anyone disagree? I'm off the top of my head there. We know an awful lot about Mars. Are we going to learn a vast amount more in the next 40, 50 years?
Yeah, about Mars.
Yeah, we will.
Lots more space, but we'll get people going now, so...
I'm not sure about that. Anyway, it doesn't matter. we'll beg to differ. Anybody else? Yes?
If we did find some sort of simple life on another planet,
Yeah.
brought us back here, I suppose it escaped a little environment, do you think it might be dangerous for us?
Well, look, when they got back from the moon, do you remember they isolated them? In case, and no one expected anything on the moon because it's got no atmosphere, it's lifeless. So obviously they'll take incredible care, all right? But I'm not too worried. I think probably this. Well, you can't say it couldn't, but they'll take great care.
Quatermass.
Yes, I know. I don't worry about it. Look, there's enough things to worry about on the Earth, including Trump. So those are minor worries. Shall we stop there?
Yeah, we should stop there. Thank you very much. Thank you, everybody.